It only ignores CV combos, not references. I'm not sure who's that. And if they are the same, can I remove this? Shit. Oh, what the fuck? No. Yeah, well, almost. That should have been copied. At least it compiles. Yay. I think I know why it calls it. Definitely progress here. That's what I mean. I got it to compile. Now we need to add back the requires. I think it should compile if I make this. The problem is it prefers this constructor over that one for some reason. If you pass something that log final copy, it can be constructed from. So in this case we pass unlocked, unlocked, that's L2, as an L value reference. Of course it can construct the unlock using this because it accepts everything. But I wanted to use this one because lock final copy can be constructed from an unlocked. Let me look at the original code. I'm talking about unlocked. Yeah, so this requires is missing. If we just add that back, would that work? Maybe. Close. So it will pick this constructor if we don't have any arguments, or no arguments or that, and not exactly one argument, or that argument is not derived from CRED. I don't think we have a CRED here, so I probably should delete this last thingy. Damn it, doesn't belong to that one. I think so. Delete. And then the enter. Let's add one more. I don't know what's going on here. Should be a VI, but for some reason I can't jump to matching parentheses. Let's try it out. Sure. It just bloody works. I also have requires here. Are they no longer needed? No, there is no requires here, but there is a requires here. You can unlock type right locks. Others use they use the movements. It doesn't explain why we have requires here. I think the requires is required for I don't know anymore. We're not testing it anyway. This test that none of the arguments that are being passed as second and on arguments are convertible to a log file. Explicit. Yeah, seems to work. Yeah, now this should not be part of the concept L value. Might as well use a not R value reference. Yeah, I don't think we need this. Well, now we have these. I can attempt to put that in my own code, because at the moment we have this compile error. In substitution, recursively required by substitution, recursively required from here, required by constraints, error, the value of is not usable in a constant expression. Well, that's not it, because I just copied this in that word. Probably should just look at the TIFF that I made. So I add a concept L value and then using that for log file copy. So here I have auto, other reference? Not really. That's too precise. With a concept L value based on formula. But it's the same as this. Absolutely. And here I replace the derived R value reference with the concept R value derived clause. So that leaves us these two. Let's replace them with what we figured out to be better. Yeah. How the hell do I have tabs in this file? Oh, I just pasted them. Well, the comment can be behind the semicolon and this closing thing, then it can be behind the or. Well, nobody understands why there are parentheses here. Oh wait, actually I do. There's an end here. Pray. Holy shit. Yeah, it works. Awesome. What is the word? Matches, I guess. Yeah. Yeah, commented this out just to test this. I mean, what I just did was not needed without commenting this out. So I didn't really need it, but it's definitely better this way. Don't want to commit this just yet. What do I have here? Git status. Give. Confused. Yeah, this is what I'm testing, vector. So we create an array, currently moving the array, that's also not necessary anymore. Just not do that. The rest is commented out. And I added the vector. So the array and the vector are exactly the same thing. We have an array and we have a vector. And that should work in the same way. Not move the array. I'll probably need to change that back because it can't work otherwise, I would say. Change this back, I mean. Array.h. Okay, store array.h. Yeah. So this was the problem that I had to explicitly cast to log final move for this to work. And now I no longer have to do that. I can just pass it like this. move other and then pass it. So definitely want to commit that one, but this here, commented that one out. Let's change that back, I guess. Or is this commented out? Running debug outputs. Commented out of that code. There. I don't know. No, I don't know. So yes. And then I guess I'll say yes to that too. Yeah, small diff that I really don't know I want to commit it. Work in progress. Right, so this now. The vector is empty. No, it's not good, of course. Should just say A30, 31, 32. I forgot what I was doing yesterday. As usual. The big change here is arrays now derived from indexed container memory region owner instead of array memory region owner. So I'm trying to make a common base class for array and vector that does the memory region owner stuff. And in the case of the array, we have to pass the start of the array and the size of the array, so we can actually make a memory region out of that. So I'm having one that takes a root graph, initialize a list and the what, and now we pass that data, and this is then the begin of the array as a character pointer, and we pass size of the element and the number of elements. I think I need all of them. Because this is the last, the base class index container memory region owner is not a template class, so it doesn't know anything about index. You have to take the type ID of index and convert it to a label right here, because the base class, well, can't do that, or I have to pass index to it. And then also pass the what. And the initializer list is just used to initialize the actual array that we derive from as well. Here we have the exact same thing, but without an initializer list. Let's keep them symmetrical. And here we have one that doesn't have a root graph and takes an L value reference to another array. Hey, post. Oh, I did eat breakfast at 3 PM, so can't wait another hour. Kowalski, I don't know anymore. I forgot. Been working too long on it. It's supposed to draw a graph of your objects. When we make a copy of an array, then we want to we have to pass a new begin. And I'm confused why we're passing the type ID again. Probably because I didn't store it or something. No. This is just using copy constructor. And here the move constructor. And this one is just otherwise the same, but it doesn't take a type ID. Maybe it's interesting to look at what the type ID is used for there in the copy constructor-ish base class. And these are without a what. This is the real copy constructor, the real move constructor. And they're otherwise the same, except that I just construct a what. So we get the what from the other, and then we prepend in front of that that this is a copy of the other. So other was this. Other was what is a debug description of the object, and then this copy of it is saying we are a copy of that thing, right? And this one says we are move constructed from that thing, because the user didn't pass a what. Well, looks all good to me, except that I'm kind of not sure why type ID is being passed here. Okay, so let's look at that. So I turn off the music because let's see. No music. I want music, but a little bit softer. Gowalski, I mean, what is all this code supposed to do? Well, draw a graph of. I'll show you as soon as I can leave my editor. Index container memory region, passing type type ID. This one. Okay, it's used in the part that is commented out. Create a key that is unique for index / root graph pair. I could have stored the hash code of it, I guess. It maybe it feels cheaper to pass it again than to store it in every array. So if you look at the other constructors that take a type index info, then you see that's not, well, this one's not even implemented. This one, for example. It's used to calculate a key, but it's not stored anywhere. So that's the reason. Okay, let's just pause it again then. Yeah. Okay. There was new array.cxx. It's on the template. Wait. Okay. I'll have my editor. So Kowalski, you're still there. I have say a few tests here. Last test is this one. So the user would create an array, and I'm sorry, but I'm not using a standard array or standard vector all the time, and I'm currently especially interested in my own arrays and my own vectors. They are derived from, it would not be this one, it would actually be utils here. So my array is just publicly derived from standard array. And the only difference is that it uses a special index type for operator square brackets and also add, of course. So normally this takes an integer, but my array take something else. So you cannot get confused and accidentally use the wrong index. It's more type safe. But for the rest, it's just an array. Same with a vector. It's just derived from a vector and then forces you to use a certain index. So in this case, the third parameter is the index, which is a utils array index using a random category, which can even be an incomplete struct. And I should not be using the same index for the vector, because this one is literally array index, which is, and this one should be vector index. So I don't know why it's even working. What vector? My vector is derived from utils vector. Passing the index. The index should be a vector index. And I'm passing an array index. Really? Why does that work? I suppose it doesn't really matter. I mean, the vector doesn't care really. Both work in the same way. But yeah, I'll explain why it is a bad idea that it works, because array is fixed. So if this is the index type for this array, then the size of 3 is kind of baked in the index, right? I mean, this index is either 0, 1, or 2. It cannot be anything else. You should not ever have an A index 4, because A index can be used for this array, and the array has a size of 3. So a value of 3 or 4 is wrong, which is not the case for the vector. So if I use this for the vector can have any arbitrary size and therefore any arbitrary values. Well, maybe you could argue, okay, but this vector has a size of 3. So therefore I can use a index. And that's actually the case here. It has a size of 3 from the beginning. So yeah, okay. But still. Seems normally you would want to have some other index for this vector, because the vector is probably not going to be as fixed in size as the array. Not as type safe this. Anyway, it works to use the utils array index for the vector apparently. And now we put into it a's. Also, both have this just a user clause here, and they can be constructed from an initializer list. Sorry, that's the initializer list. So you have graph around it now. This is the root graph. So because it is a cppgraphviz array and not a utils array or a standard array, we have the root graph here as first argument, and a what as it just describes what it is. So then I use the name of the variable here as the third argument. And well, if you don't do that, if you don't want to debug stuff here, then this is just empty, right? This is a macro and it becomes empty. So we just construct from a 20. We construct an A from 20 and an A from 21 and from 22. And this is not there, and this is not there. It's 1. Same here, but then with 30, 31, 32. So you have to change the code. You have to put this namespace in front of it instead of utils. And you have to say which root graph we want to add this to. But that's about it. And then you can draw the graph. So the result is that you can do, and now you can see that we have an array called AS. There's going to be an edge, so an arrow from here that pointing to, so points to there, to the top here. So we have an AS in the root. That's the name of the variable, that's the name of the array. And it points here, you can see the type. It's an array using a index as index type. And the size is 3. And the content is an A value 20, an A with value 21, and so on. And exactly symmetrical, we have a vector which should point to an array of size 3 here, which is an A of 30, 31, and 32. So now we have a graph that shows our objects. And the whole idea is, of course, that if you then mangle that through an extremely difficult program, threading and moving objects and growing vectors and vectors that are moved in memory and, well, everything you can throw at it, that still shows you the correct output. And that was the hard part. To keep that working thread safe. Jeremy says, I'm thinking about developing a finite element simulation engine. I'm not sure what you mean. What is a finite element simulation engine? That looks pretty advanced. I guess the answer is yes, because I see here 2 people. Again, 2 people. There's 1 people. Object-oriented finite element solver written in C++. Maybe you want to look at that one. Written by a single guy. I guess it depends on your experience and stuff. Yeah, I don't know, man. I mean, I would say, of course it is possible. And I think that the right mindset is to just begin. I mean, if you are afraid, oh, it might be too difficult, then you will never become a top expert in the world because, well, you didn't start all those things even. It's probably going to be too difficult. But if I look at myself, who never was afraid of anything, I just started doing it, it cost a lot of time. So you could, if you were me, I should say, instead of if I were you, I would probably just begin, and then 10 years later, I would realize that I should never have started it. But in the meantime, 10 years would have been passed, you know. And then by that time, maybe you can say, well, maybe 7 years, but that's the absolute minimum. And then you say, okay, it's too difficult. And if now I stop, I'm going to have wasted 7 years of my life. But the question is, did you really waste 7 years of your life? I mean, the project isn't finished, but you did become a better programmer. You did become more of an expert, right? So it's a learning experience. But yeah, well, so I would say, dude, just start and only work on it if you think it's fun to work on it. If you feel stressed by it, then I wouldn't do it. Okay, let me think about what I want to do next. My memory's so bad. I mean, not perfect. That's what I really want to say. What I did was I split array up into, no, it was already like that. So I just renamed the array memory region owner to index container memory region owner. And I don't think I changed anything. Except that I commented this out. Why the hell did I do that? What is this? So that one is a weird one. And here I have something that is completely empty. Also very scary. Oh, it's a move. probably okay. And then the on memory usage, I don't think I changed anything here. Call initialize on elements. That's the end. Feels like these are still what they were for the array at least. And this probably as well. I wouldn't delete something, so I would comment it out. So is this empty? It was that empty. And this here is commented out. Yeah, why? Let's begin with uncommenting the debug output, because why the hell is that commented out? No need to comment that one out. And this, why is this commented out? Oh, it's a copy. Okay, let's see that things break if I copy it. I don't think it should be commented out, so things should break if I use this one. Copy. This is a move. Probably make a copy somewhere as well. Array. I never make a copy. Sure, I make a copy. Maybe this one, D. And just make a copy. We make a copy called A2, and we don't move it, but we make a copy. That crashes. That looks like a deadlock detection. That was probably due to the debug output. Still. Right. Yeah, okay. Well, GDB. Oh, it's another assert. Only set the root graph once. Hmm. What? I set a breakpoint at 244. I mean, I didn't. I did I? 244. Yeah, break. Why didn't it stop there? Dude, what the F? No, it stops there. What? Oh, this is even more funny. No, it's not. Sorry, set root graph is of course not called twice. It was just said because, okay, where am I? Print this item pointer FD308. Let's see it again. Hmm. Or I guess I can print 0. Just 0. We have a root graph tracker here that looks like it's not set. Do we have another root graph tracker? Nope. So that must be the one then. Or we have a tracker that points to it and we don't see. This says tracker is a shared pointer to a node tracker. Empty equals get da, 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 da. No, I think this one is the one. How do we get to it? Okay, so I do print that, the dot. It's not a primitive mutex. Tracker. That's why it looks like it's part of the tracker. Nope, it's not. Well, in that case, maybe you can just do that. Yep, it can. Why does it not print what the contents are of this thing? I bet it's just a wrapper around a pointer. So let's say print the contents of some void pointer at this address. It's gonna be 0. No, that's not what I meant. In a minute. Or is it? Yes, it is. Okay, so I do watch that thing. Hopefully. Continue. And now it was set to that value. So if now go up, clearly that's where it happens, right? Root graph tracker. Anyway, I'm gonna go up anyway. Yes, all the way till main. AS2. So if now I print AS2 at 0, then the root graph tracker is this value. Yay. So yeah, but I already saw that. So that's where it happens. It is already being set. This is used by node when it must be added to root graph. Hi, Len. We just copy an A, and I guess I want the same root graph. No, I don't. Well, of course I want. Oh, there's only one root graph. Yeah. So we're copying each element, which are type A. And then if I copy an A, copy an element, aka copy an A, now we initialize the root graph of the new A with the root graph of the old A. Because, hey, it knew the root graph, so now we know it too. I mean, how else do you get it, right? Makes sense. It's not the same as the parent graph. But now it turns out that we are copying inside a memory region owned by an array. So the root graph is already set. I would almost think that I never tested copying an array. should also no longer be required. Oh, wait, actually it does. Never mind. In case you're wondering, that the log final copy takes a read log of other. So we're going to copy other, therefore we log it with a read log. And that happens here. Oh, here the thing is created. The lifetime of this thing is till the end. And now we're done with copying as well. And then the read log is unlocked again. So yeah, I'm thinking hard here. Let's go to the test code. Oh, already there. So in the test program, we are here. Copying from one array, namely AS, this array, to another array, AS2. That's going to call the copy constructor of every element. And the elements are A. Now these elements already know which root graph they belong to, namely G0, and that went as follows. G0 here is passed to the cppgraphviz array, which remembers it, and registers a memory region. And then these are constructed, so that's an A, here's another A. They are constructed and then copied into the memory region. And at the moment they were copied into the memory region, they say, hey, this memory region is owned by someone, and they say, hey, someone, I just arrived here, what is the root graph? So that then the root graph was set in the A. Now the A also knows what the root graph is. So every element in AS knows that now. And we're copying that. And then the copy constructor apparently says, I'm copying this thing here, copy one A to another A, let's copy the root graph as well. So then each element gets, even if it's copied one by one, each element is just yeah, well, copying the root graph, right? So it's initialized with the root graph. And I would expect that this thing also registers a memory region. Although that would not be necessary, not really. Let's follow the array copy constructor and see what happens. See if I can figure out what happens. threadsafe array. It's not per se a pure copy constructor because we're also passing a new string here as a what. So it's not this one, but we are using that one. It's my own color scheme, so yes, it's new. Now this should be doing the registration of the memory region, I guess, if it is done at all. And then we copy stuff over. So assuming that registers the memory region, and I guess it does because it's even passing a start. The new this pointer, which points to the beginning of the array. The size we can still get from other, I suppose. And then we're going to do this, which is copy constructor of the array itself, which is going to copy each element one by one, and those then don't know any better than that is exactly the same as what happened here. They were just copying into a memory region that is registered, and therefore they will try to set their root graph as known by that memory region. And therefore it's set twice, because we already set it before that happens, apparently. That's, I must say, what is confusing me. Okay, let's continue. So this index container memory region owner, there's two things that confuse me. I mean, I made changes. This already worked before. So what I'm seeing now is something that apparently never worked, right? Copying an array. It just goes wrong. So is it now caused by my latest changes? Or have I just not even tested copying an array? Can hardly imagine that. If you assume that I tested copying arrays before, then it did work before, then I must have broken something, but it seems so unrelated. Unrelated to renaming this base class. That's basically the only thing I did. Maybe I should just go back using git to an older version and then try copying an array, see if that still works there. Okay, which one is this? Other begin type ID what? That's this one. So other begin type info and a what. That initializes a new memory region and registers it, starting at the new begin and using the old size. It remembers the begin and the element size and the number of elements and everything. And then we have not doing that. Then we are not doing this. Maybe that is the whole reason. Could that be the reason? Maybe we should just try it out. This was beginning with, you know, wondering. I wanted to break, and then I was going to uncomment this and then see if it was fixed. And then I ran into this. Maybe this is the break. I don't know. Maybe that's how it breaks. Let's try it. Nope. I would almost say thank God, because I have no clue. what that would have been then. I would feel a lot better though if I would see this fail in an earlier version as well. Now I'm going to assume that this register memory region and not what happens here. That's more the contents of the new copy, table node and the label and whatnot. Still want to see it fail, but let's keep it uncommented at the moment. Okay, so was probably also not related, but let's keep it commented out also for the moment. Then let's look at the base class memory region owner. Yeah, that definitely registers it, right? Register new memory region owner. So this is registered now, and then we should end up in inform owner of at the moment we get copied there. But why does that happen? After we already set the root graph in the element. So I have to go to the what do I call here? I was following the copy constructor of array. Yeah, now we're going to copy array here. No. Okay, just utils array. So this is not going to do anything except calling the copy constructor of each element at a time. So we have to follow copy constructor of A itself. Struct A. Int log final copy. Here's the copy constructor. Which is implemented in terms of this one. Which then calls a log final copy, comma somewhat. So that would be this one. Which doesn't do anything special except pass that to the rectangle node, the base class. Which just uses a label node. This one here, constructors. And then we have here log final copy other what, so it's this one. And then that means we just pass other to node. I don't think that's now we enter threadsafe namespace, so unlocked it's still no. Track object. I think it is calling this one. Original, yeah, so Doesn't do anything, just passes it to the unlocked itself. And unlocked unlocked is derived from the T, yeah. So the whole thread safe namespace doesn't know anything about memory region stuff, so it has to be the T that we construct here with also with a copy constructor, obviously. But we do pass the log final copy. So unlocked. Yeah, this one. Should be this one, and that is then dereferenced. So we use the copy constructor of the first. Well, no, we use the copy constructor of the T itself. I mean, it's dereference is unlocked, but unlocked is derived from the T. So we're using the copy constructor of T directly. And T is the first template argument, which is the first template argument here, track locked type, which is locked node. So we're calling the copy constructor of locked node. Copy constructor, right? Not even a what, so this one. There's this one. It does some parent graph stuff. Adds itself to the parent graph, but nothing with root graphs or recognizing memory region. So I'm going to assume that happens then here in the item template. Oh, right. Item template is now constructed using the root graph tracker. Now we're getting somewhere. Item template. I think it's this one, right? Root graph, comma this. Can choose between this one or the next one. I believe it was this one. I saw this comment. This one is used if T is a node tracker. I have no idea what it is. Root graph tracker, right? So it's not a node tracker. No, it's not. What the hell? T's tracker. Item template. I don't know. Let's just assume that I remember the comment correctly. So this one is being used. And then pass object, the root graph and the object to item. I still don't see any memory region anywhere. Is it using the default constructor of tracked objects? It's also a base class. Apparently. Item. Okay, so that just passes it on. Root graph tracker and object is an item pointer. That will be this one. So yes, clearly the root graph. Yeah, okay, now we are there. I started losing hope. I thought we're never going to see the memory region stuff, but here it is. And the root graph is set first. So this initializes the root graph of the item, and then we're going to look at memory regions. We get a memory region, and then we inform the owner of the memory region, and that then is going to set the root graph again. So the whole fact that we initialize the root graph here and then call inform owner of is the problem. At least since we do not allow the root graph to be set again. Yeah, and then there's this one. Using root graph tracker without an underscore. Uh-oh. I think this is a good moment to stop and go make my dinner. Because now I have something to think about. Yes, I complain about my memory, but I can still think about this while I'm cooking. I know.